Today we will be doing a short video on how to do the 2024 edexcel higher tier max paper 2 final question. So let's read the question first. This question says that A and B are points on a circle and this with a center O. MAP and NBP are tangents to the circle. So what we can do, so let's see, so MAP is this line. I have a better idea. MAP, as we see, is this line over here. Yeah, MAP is this line over here, and NBP is this line over here, which we can also underline. And what do we know? And we know that both of these are tangents to the circle. What we have to do is that prove that AP equals BP. So as some of you already know, this is actually a circle theorem in itself. So all this question is that it's just a proving the circle theorem's question. However, it is good to know that this is not the most common circle theorem which you're normally asked to prove. So most people probably don't have the circle theorem memorized, and therefore it is something which you would have to work out in the exam. Anyways, to start this proof, what we first do, we want to draw a line. Well, we want to draw a line from O to P. This line over here. Actually, you know what? Let's use a different color. We want to draw a line from O to P. So this line is OP. What we can also do is draw lines from O to A, label this OA, and a line from O to B, which we can label as OB. Sorry about that. Let's get our markings back. Here we are. Okay, so first, as you can see, this triangle, both of these triangles already look like right angle triangles. However, we do have to prove it. To prove it, as one of the most important, we can use one of the most important circle theorems, and that circle theorem is that angles between a radius and tangent are 90 degrees. This is our radius here, and this is our tangent here. Because a tangent, remember, tangent is just a line which touches a circle at one point. So this is our tangent here. And therefore, what does this show us? This shows us that OBP is equal to OAP, which is equal to 90 degrees. That's step one. Now, what we also know is that OA must be equal to OB. Why is that? Well, if we look at it, O is the center of the circle, A is a point on the circumference of the circle, and B is a point on the circumference of the circle. Because both of them are points on the circle and O is the center, we know that OA must be a radius and OB must also be a radius. Therefore, we can write our proof that OA must be equal to OB as both lines are radii, which is just the plural for radius. Now, final proof we can use. We can say that OP is common to both triangles. So as most of you can see by now, this is not even a circle. This is a circle question, but this question is actually testing your skills on congruency. What we're doing, we're proving both of these triangles are congruent. Now that we have our number one proof, number two proof, and number three proof. Let's walk through these proofs. Our number one proof says that both of them have a common angle of 90 degrees. Both triangles have this common angle of 90 degrees. What does our second proof show? Sorry about that. What does our second proof show? Second proof shows that both triangles have one side which are equal in length. In this case, OA and OB, they must both be equal in length because both of them are radii. Final one, well, our final proof is also showing, just like our second proof, that both triangles have another side which is also equal in length. In this case, it is OP which we're talking about. OP, and because obviously this side is common to both triangles, they have another side which is the same length. Therefore, well, what does this show us? This therefore shows us, let's rub this out for some space. Obviously I'm writing a little bit big here, so we don't have as much space. So what does this show? This therefore shows that both triangles must be congruent because of SAS. SAS stands for side, angle, side. And if we go back, we can see that OP is our equal side here. We can say that hold on a minute. We can see that OA and OB are our equal sides here, and we can also see that, not this again, and we can also see that angle OAP and angle OBP are our equal angles here. Now going back to the question, well, it's asking us to prove that AP and BP are equal. If we remember what congruent means that both triangles OAB, this triangle here, OAB, and also, sorry, not OAB, what am I talking about? OAP, and also triangle OBP, both these triangles here, they're congruent. What does congruent mean? Congruent means that all their sides are exactly the same length, and all the angles are exactly the same size as well. Or aka both triangles are the exact same. There's no difference between them at all. The only difference which you can actually have is that they may be in a different orientation, but other than that, they're the exact same triangle. If you were to place them at the same orientation on top of each other, you wouldn't even be able to tell that both triangles are different triangles, sorry. So this can help us to prove that AP equals BP, because if they're the exact same triangles, then what is one of the rules of congruency? All the sides must be of equal length. Therefore, as both triangles are congruent, AP must be equal to BP. And again, why is this? Because both triangles are congruent, and if they're congruent, all the angles are of the same size, and more importantly, all of the sides are of equal length as well, which therefore mean that because both these triangles are the exact same, let's rub off some of these markings, as both these triangles are the exact same, just in a different orientation, this means that BP must also be the same length. BP must also be the same length as AP over here. Hence, we have proved that AP must be equal to BP. Thanks for watching.